Theory of machine, graphical method of velocity and acceleration. In a slider crank mechanism, crank AB 20 mm and connecting rod BC 80 mm. Crank AB rotates with uniform speed of 1000 rpm in clockwise direction. Find angular acceleration of connecting rod BC and acceleration of slider C when crank makes an 60 degree with horizontal. Now draw one horizontal line to draw the configuration diagram. The configuration diagram can be drawn with a scale or can be drawn with a dimension as it is. Now here crank AB 20 mm and draw BC is 80 mm. Draw one horizontal line, mark one point on it to draw the 60-degree angle of crank AB. Mark a 60-degree with horizontal to draw the crank. Now I am drawing the crank which is a 20 mm. So I am taking a dimension of 20 mm with a 60-degree angle. Now connecting rod is 80 mm, so take a dimension in a compass, that is 80 mm, 8 centimeter. Keep a point on a B point and make a chap on a horizontal line, so you will get the connecting rod. Join B and C point. A point A, B and C. C is the slider, so draw the slider at that point. Slider which making a reciprocating motion in between the guideways. Crank at a 60 degree. Give a dimension to the configuration diagram. Crank is rotating at 1000 rpm. I am giving the dimension, that is 20 mm, and connecting rod which is 80 mm. Now we have to draw velocity diagram. For that we have to draw perpendicular lines to the each link. So for that, mark a point anywhere on the sheet, and from that we can draw the lines. As crank rotates in a clockwise direction, so we have to draw the line in a downward direction. To draw the perpendicular lines, align the scale and the line so that we will get the perpendicular lines to that link. Here I have drawn the perpendicular line to the crank. For that we don't have a dimension, so we have a n is equal to 1000 rpm. From this we can calculate the omega. Omega is equal to 2 pi n by 60, equal to 2 pi into n is 1000 divided by 60, equal to 2 pi into 1000 divided by 60. 104.71, that is 72 we can take, or 719. 104.72 radian per second. Now 104.72 radian per second is omega AB. Now VAB is equal to R omega AB. R is the length of the crank, therefore equal to R, that is 20 mm into omega is 104.72. 20 into 104.72, 2. 2094.39 mm per second. Now we got the velocity of crank AB 2094.39 mm per second. Now we have to choose a scale, as we can't draw the to that scale of VAB. So take a scale 1:100. So 2094.39 divided by 100, we will get the 20.94 mm, or 2.094 centimeter. So we have to mark the 2.094 on a line which is perpendicular to the crank AB. So now I am marking it 2.094 centimeter. 2.09, that is almost 2.1, near to that. Now as crank rotates in a clockwise direction, so we have to make a downward arrow to the line AB. The point which is come, name it as a small b. Now we have to draw the perpendicular line to the connecting rod BC, making scale aligned to the connecting rod, so that we will get the perpendicular line. Now draw the perpendicular line from point B in upward direction. As we don't have a dimension or any other parameter to calculate that dimension, so just draw it. Now slider having a reciprocating motion in a horizontal direction, so we have to draw the line in a horizontal or linearly from point A, that is slider moves in a fixed guideways, so that we have drawn from point A. Mark arrow ABC. Here we got the velocity diagram. From that we can draw the acceleration diagram. For the acceleration diagram, we have to draw one table which are having 4 columns. Serial number, second link, third column, length of the link, fourth column, velocity mm, velocity next column acceleration, that is fc, centripetal acceleration. fc equal to v square upon r, v mm per second, square, acceleration mm per second square, length of link in mm, link. Now serial number 1 and 2, first link is a link AB, length of the link is a 20 mm, and second link is a BC, AB is a 20 mm, BC is a 80 mm. Now velocity of link AB, we have a VAB equal to 2094.39. Velocity of BC, now we have to calculate the velocity of BC from the velocity polygon. So measure the small BC, take a dimension from small bc, so we will get the vbc equal to 0.95 into scale. vbc is equal to small bc into scale, so vbc equal to 0.95 into scale is a 100, but we have taken the vbc in a mm per second, so we have to take a 0.95 in a mm, that is 0.95 is a centimeter, we have to take it in a mm, that is 9.5 into 100. Total velocity polygon is in mm because VAB is equal to 2094.39 mm per second. Therefore VBC is equal to 9.5 into 100 equal to 950 mm per second. Therefore write it in a table. Velocity of BC is 950. Now FC is equal to V square upon R, that is 2094.39 bracket square divided by R is the length of link, that is 20. Next length for BC, FC equal to 950 square divided by 80 equal to, now calculate it on a calc, 2094.39 brackets square divided by 20, 21932 3.47, and for BC 950 square divided by 80, 11.281.25. Now for acceleration polygon, mark a point anywhere in the sheet. To draw the FC, we have to take either parallel lines to the configuration diagram or perpendicular to the velocity polygon. Now for that we will take the parallel lines to the configuration diagram. So draw the parallel line to the crank AB first from drawn point A dash in a downward direction because crank is rotating in a clockwise direction. Name it as A dash. We have a acceleration, centripetal acceleration for AB is a 219 323.47 in mm per second square. So we have to take a scale. Now take a scale of 1 is to 1000, 10,000, because we have got the 219,323.47. Take a 1 is to 10,000 scale. So by dividing the 10,000 to the FCAB, we get the 2.19 centimeter or 21.9 mm. Due to the scale, draw it on a drawn line, mark it as a B dash. Now next link is a BC, that is connecting rod. Connecting rod is a oscillating link, so that it have a two acceleration. First one is a tangential acceleration and second one is a centripetal acceleration. We have a centripetal acceleration which is drawn parallel to the connecting rod BC, and we have that FCBC equal to 11,281.25. Now dividing the FCBC by a scale, that is 10,000, we will get the 1.12 mm, that is 0.12 centimeter. Here I am drawing the 0.12 parallel to the connecting rod, that is centripetal acceleration. Now next is a tangential acceleration, which is perpendicular to the centripetal. So draw tangential acceleration perpendicular to the centripetal. As we don't have a dimension, so just draw it, which is 90 degree to the centripetal. Give a name to the centripetal as a FCBC. Now next one is a slider. Slider is having a reciprocating motion. So just draw a line parallel to the line of action of slider, that is linearly, through the A dash. That line through the A dash intersects the tangential acceleration at point C dash. Now joint B dash and C dash. Now make arrows having a direction of slide acceleration. Here it is FTBC, A dash, B dash and C dash. A dash, B dash having a downward arrow because crank is rotating in a clockwise direction. Now for a calculation, FTBC equal to C1 C dash. Here is the C1 C dash, that is tangential acceleration. Measure it, C1 C dash into scale. C1 C dash is near about 19 mm. 19 into 10,000 equal to 1,90,000 mm per second square. Now as we know, the FTBC, tangential acceleration, equal to R alpha. So 1,90,000 equal to R, that is the length of connecting rod 80, into alpha. Alpha equal to 1,90,000 divided by 80 equal to 1,90,000 divided by 80 equal to 2375 radian per second square. Here is the first answer. Now acceleration of slider, A dash C dash, slider A dash C dash into scale. A dash C dash is near about 8 mm. The 8 into scale is 10,000 equal to 80,000 mm per second square. Mm per second square. Here is the second answer. So here we have both the answer.